Hello everyone and welcome back to the Meshmixer Master Course. This is Joe Fairley, certified prosthetist and owner of Ascent Fabrication. Today we are going to go through how to design a prosthetic socket through what we call design for additive manufacturing techniques. So design for additive manufacturing is a train of thought we use to think about how we are actually going to 3D print this specific device. In this case, we are going to be using Vase Mode with a Filament Innovations 3D printer. And in that case, it is a very specific design pathway that we take in order to get to this end product. So, without further ado, here we have a 3D scan of a below-the-knee right residual limb model. You'll notice that on the inside there is no data, so it is just a surface scan. On the right hand side we do have the objects browser, which I can move around and increase or decrease the size of the browser. What I will do initially is go up to view. You can either show or hide the object browser initially. You can also show or hide the printer bed. In order to make sure that we are in the correct units for what we are designing, I have right now the Filament Innovations Icarus 3D printer chosen to show me the build volume of this particular print. So the below the knee model here looks sufficiently scaled. Otherwise you wouldn't even see this scan. It would be so micro small that you wouldn't see it on the grid at all. And this was going to have to do with when you take a 3D scan, when you are exporting that scan in millimeters, centimeters, or meters. And typically, working with Meshmixer and the couple slicer programs we use, we want to be exporting our scans in millimeters. If you have the ability to download your scan as an OBJ file, that will allow us to view the color in the scan. If it is an STL file, you will not be able to view the color in the scan. In order to check to see if our scan has any color, you can go up to File and Preferences, and instead of Group Color Mode, we can go to Vertex Color Mode. In this instance, we don't have much other color other than this gray color, but if we had some kind of indication of any bony anatomy landmarks that were drawn either on the plaster mold or directly on the patient's limb over the liner as we're scanning over the liner, then they would be viewed here. So otherwise, we're going to be working in the group color mode. So here, what I like to do is designate the object browser as our history tab. So this initial scan, the number 2 BK for locking or suction socket, I'm just going to rename this one.originalScan and hit enter. You'll notice that I have a couple different components here also in the browser that we're going to be using from time to time included into the design so that we can complete the full product. In this instance, we are going to be using the Bulldog Lock receiver and the Bulldog Lock dummy to create a Vase Mode either test socket in PETG, preparatory socket in polypropylene, or FDM definitive socket in carbon fiber polypropylene. The design is the same for each 3 of these sockets. However, the print settings are going to be different on the back end. So, with number 1 original scan, we are going to number the scan that we use so that when we go to duplicate, we turn off the visibility of the first one, and we're going to name this one number 2, the clean scan. I'm numbering these scans so that I can open up Meshmixer again, and the object browser is going to be all jumbled up, so I can use these numbers to indicate for myself as I practice these steps which order I actually perform them in. So the clean scan here, number 2, the first thing that we're going to do is close off the proximal end. And before I do that, I have a pretty kind of wavy, jagged proximal edge here. I'm going to smooth that out by going to Sculpt, under Surface, Brushes, Robust Smooth, turning down the strength to 30. You can either use the drag bar or you can type into the box here. Turning the size down to about 30 as well. And in this case, we have some rather smaller products here on the right hand side. So right now the size 30 is actually quite small. I'm going to just increase the size of that brush in order to give myself a little bit more working room. You will also notice that the brush size is big or small if you have to resize the model in different units in either a scale of 10, 100, or 1,000, going from millimeters up to meters. In order to fix that, what I would do is export that scan, close Meshmixer, open up a new instance of Meshmixer, and then re-import that scan once you have done the scaling. What I'm doing now is just smoothing around these trim lines in order to get a fairly smooth surface that I'm then going to select and pull upward. Alright, so we'll go to Select, turn down the size. We're going to click directly next to the blue line, hold down Control on our keyboard, and scroll forward on our scroll bar on our mouse so that we can either increase or decrease that selection. Next, we're going to go to Modify and Smooth Boundary. I'm going to turn the smoothness all the way up and the iterations all the way up. We're going to hit Accept. Then we're going to go to Deform, Transform. We want to be in the world view instead of local view. And I'll use this green arrow to just pull this up so that I have a little bit more working room just proximal to these trim lines. We'll accept that. And then I'll double click on the color of the main face of the part of the scan that I just created. I'm going to go to Deform and Smooth. I'm going to turn down the constraint rings all the way and turn up the smoothing scale to about 50. I'm going to accept that. And now go into Sculpt, under Surface, Brushes, Robust Smooth. We'll turn up the size again. And what I'm essentially doing here right along this line is combining these two parts of the scan. If you don't do this, then there could be little micro holes along the scan itself. So we've gone all the way around. Now I'm going to go to Edit, Plane Cut. I'm going to use the big blue arrow to position the plane of what we're cutting upward, and use the little blue arrow to move this cursor upward. And I'll just go a little bit proximal to these trim lines. I'm going to be using Remeshed Fill and Cut Discard Half, and hit Accept. Now we have a closed off shape where we have a completely flat proximal end that is going to be optimal for our Vase Mode printing purposes. In Vase Mode, we are printing in one continuous travel path. So because of that, we have to print proximal to the trim lines. We won't be able to print these trim lines as if they were cut out in this model. It's not a lot of material to waste, and it is the fastest way and strongest way to be able to produce an FDM part. So, a couple other things that I might notice here. We see some striations on the scan in a couple different places, and maybe a couple pokey points, little ridges along some parts of the scan. I do want to smooth those out because those could potentially be visible in the scan itself once we print it. So we'll go to Sculpt, Brushes, Robust Smooth. I'm going to turn up the size, turn down the strength to about 15. And I'm going to go around the model and smooth out those particular areas that are a little striated. Now at strength 15, I'm really not reducing the volume of the scan. I'm just simply very lightly smoothing it out. Alright, now that we have everything smooth, we're going to call this our clean scan. Now, in between these different steps, we want to end up saving as we go, because this definitely will be a little bit finicky as we continue on with Meshmixer. We want to make sure that we're saving as we go in order to save our progress and make sure that we can come back to it should Meshmixer want to crash at any point. Alright, now that I've saved Meshmixer itself, I'm going to duplicate that clean scan. If I click on it, duplicate scan, sometimes it duplicates it twice. We'll just delete out that second duplication, we don't need it. We're going to turn off the visibility of the first one that we just had turned on. Go to the second one here, and this is going to be our step 3. We want to offset by a nominal amount, 0.05 millimeters, and we're going to extrude by 4 millimeters, and enter. So I had said in the beginning that we want to use the Bulldog Lock dummy and the Bulldog Lock receiver. What those particular devices look like, if we use the eye here to show them, and we turn off this one that we're actually working on, there is a cylindrical receiving end that is 4 millimeters in wall thickness. And if we take a look at the inside view by turning off the visibility but having the name selected, we can see that the distal end is actually 6 millimeters, the walls are 4 millimeters. And when we go to import these items into Meshmixer, they're going to import in this exact location where they should be. So the Bulldog Lock dummy is in the position where we want it. We're going to use the dummy as a reference point to now move our step 3, the residual limb, into alignment with the Bulldog Lock dummy. So first, you'll see these different colors on the proximal edge of the scan. Those indicate different face groups of the scan itself. I'm going to go to Edit and Generate Face Groups, and I'm going to turn up the angle threshold to the R in threshold. What that's going to do is it's going to take all the very little triangles that would otherwise be very multicolored, and we're just going to turn them into one continuous color on the main body of the scan, and then one color on the proximal edge. And hit accept. Now, we can use the transform tool under edit while we have the residual limb selected to, under the world view, we can use the arrows to position the residual limb exactly where we want it to be. Alright, so from the anterior view, we look pretty good there. From the medial view, we also look pretty well aligned there. So we'll hit accept. And then in order to figure out how far down into the dummy we actually want to bring the limb, I'm going to uncheck the visibility of the dummy, hold down Control on my keyboard, and left click on the name of the dummy. So now you can see directly through the dummy, and you see the distal edge of the residual limb. We're going to use the transform tool then to bring this up to the very proximal edge of the dummy. Now, based off of the concavity that is within the bulldog locking mechanism itself, it's a 10 millimeter concavity to the center. So that means that we technically could bring this down. If you noticed, this says about 9 millimeters there. If we go down to about 0, and so that was 9 millimeters. If we go down to -1, that would be about 10 millimeters into the bulldog lock dummy, and that is as far as we can basically go to bring this residual limb into the lock itself. Otherwise, we're really impeding on the distal limb shape. In some cases, you might want to give it just a little bit more room, so maybe you only bring it down 8 to 9 millimeters. Now in this case, we have a rather narrow distal limb shape, so you do see these triangular spaces on each side. That is simply going to be space in the socket, which is not unlike the traditional method of placing a bulldog lock dummy onto a plaster mold. Some people would end up filling these gaps with plaster so that you have a smooth transition, and because of how the receiver is designed, you will end up still having this smooth transition in there. If you had a rather wide distal limb shape, you would really want the distal limb shape to be touching on both sides, front to back and side to side, as far down as it would end up going. So from an anterior view, I see that I am contacting these two outside points rather nicely. However, from a medial view, it looks like I'm actually impeding on the distal limb. So I have to go back up to where we're just touching on either the medial or the anterior view. Again, in some cases, you're going to end up having little triangular holes in the socket, but that's not unlike the traditional method of fabricating this. Now, with a narrow distal limb, I know that I'm going to be too far down into the dummy, so I'm going to go back to our original kind of starting point before I started this, and that was about 9 millimeters into the dummy itself. Again, you can go up to 10 millimeters into the dummy. If you go less than 10 millimeters, you are lengthening the socket. If you go more than that, then you're short socketing the person. So we'll start out about 9 millimeters just to make sure we have enough room, and hit accept. And now we want to end up creating this offset 0.05 millimeters and extrude 4 millimeters. So at this point, this is where you are basically thermoforming plastic over this mold, but rather what we're going to do is select this whole outer surface, bring it away from the model ever so slightly, And then we're going to give that surface a thickness. So I'll go to Select, double click, left click, and you're going to select the entire main body of the scan. You'll notice that the proximal edge is not selected. That's fine, that's what we're looking for. We're going to go to Edit and Offset. So we've offset by 0.05 millimeters, and we can click into the box below it. We're going to allow Meshmixer to go through its computation and solve this. We're going to hit Accept. Now, while we are still in the selected tool here, underneath the Edit, we're going to go back to Separate. And now, clicking on just the proximal edge here, now it is a completely separate part of the scan than the outside shape that we wanted. So this other part of the scan we can simply delete out of the equation. We don't need that part. Selecting the offset 0.05 millimeters again, we're now going to go through the steps to extrude this. So up at this proximal edge, the blue line, if we simply extruded this right now, would end up with very spiky points that would be coming off of the proximal end. So we're going to go to Sculpt, under Surface, Brushes, Robust Smooth. Strength about 30. Our size is going to be appropriate to the limb shape and the model. Typically we're at about strength 30, size 30. And you'll notice that I'm actually following this shimmering bit of triangles that I'm basically remeshing and smoothing as I go along this proximal edge. You'll notice that my cursor is just below the blue line as I do this. I'll go all the way around the model. Once I've gotten all the way around, now we are going to select, double click on the main face of the model, edit, and extrude. We're going to click into the offset and go for 4 millimeters in a normal direction. And at this point, we're going to take a look around the scan to make sure there aren't any other artifacts or what I would call craters in the scan, such as this. So right here, we have a portion of the scan where there was a micro hole that we otherwise have to smooth over to close that before we do this extrusion. So we're going to cancel, sculpt, and you might see this small black kind of shimmering aspect here. We'll go to Brushes, Robust Smooth, turn down the strength to about 15, and go over that one area. Now going back to Select, double click on the main face of the scan, edit, and extrude. 4 millimeters. Direction goes to normal. Look around the scan, make sure we didn't miss any others. Looks pretty good. And then we're going to look at these top trim lines and notice that they're ever so slightly just not crisp and rounded. So I'm going to harden 100, and that's going to give me a nice crisp finished edge. I'll hit accept. And then sometimes where some aspects of the socket are actually kind of folding in over itself, I will go to the sculpt tool again under Surface, Brushes, Robust Smooth, and just target that area ever so slightly to close those little gaps. Now, with the very proximal edge, I want to make sure that for Vase Mode, we are printing one last completely flat layer. In order to do that, we're going to go to Edit and Plane Cut, move the cursor proximal, click on the big blue arrow, and we can just plane cut this just proximal to the trim lines so that we're not wasting too much material. You'll notice on the proximal edge that we have a different face group now, whereas if I went up to the very proximal edge, you'll see exactly where that face group ends up changing color. So I'll go down just proximal to the trim lines, under Remeshed Fill, Cut Discard Half, and hit Accept. Now I have my offset 0.05, extrude 4 millimeters. This is basically our Vase Mode socket. However, now we need to attach the Bulldog Lock receiver. So I'll save as I go. I'm going to duplicate this part. Again, it ended up duplicating it twice. We can just delete out the second one, turn off that first scan, click on to the second scan below it. We're going to turn on the visibility of the Bulldog Lock receiver, and clicking on the name of the receiver, we're also going to duplicate that. Turn off the visibility of the receiver, and you'll notice that going up into the socket, you actually see the receiver on the distal aspect of the socket. Due to the nature of Vase Mode printing, we will only see the outer edge that is printed of this receiver. So we actually won't see this cut out part or the receiver going up into the model. In order to set up what is actually going to be the socket, we'll name this for test socket. Now with the test socket selected, I'm holding down Control on my keyboard and left click on the Bulldog Lock receiver that we copied. And we have a couple different options over on the left hand side under Edit. We have Combine, Boolean Union, Boolean Difference, Boolean Intersection. For the purposes of printing in Vase Mode, you only want to combine these two scans and tell Meshmixer that this is basically just one scan. So when we have unchecked the visibility, you'll notice that these two scans are now together, and that's exactly what we're looking for. Now, when you have a rather narrow distal limb shape, you might think, I don't really need any reinforcement because there aren't very large overhang angles. However, right at this point where the receiver ends up meeting the socket, that's going to be one of the weakest points in the socket. So we really want to use these reinforcement pillars, turn on the visibility there, to make sure that we have any overhang angles actually supported, and the socket is going to be stronger that way. So we'll click on to the reinforcement pillars, and you'll notice that they're turned about 90 degrees. So I'm going to go to Edit and Transform. In the world view, I'm going to use the red arc. If I keep my cursor on the red arc, I can move it by any number of degrees. However, I want to move it by exactly 90 degrees. So I'm going to move my cursor out to the grid, the rotating grid, and move it exactly to 90 degrees. I'll then move the reinforcement pillars up into place, and I want to be rather even front to back, anterior to posterior, and side to side, medial to lateral. However, I don't want the tops of these reinforcement pillars actually poking out of the socket. I want them to disappear up into the socket as they're printed. So in order to achieve that, we can decrease the size of the reinforcement pillars as they are, if we check the uniform scaling button, you can decrease this to 90% or 0.9, and you can increase it all the way up to 1.1. And in between those numbers, they will still print very well in Vase Mode on the Filament Innovations printer with a 2.5mm nozzle with our PETG polypropylene or carbon fiber polypropylene. We have not tested this really with any other materials or nozzle settings, so this is exactly what it will work for. We'll move these into place, and if you notice that the reinforcement pillars right now are shimmering on the bottom aspect of the receiver, that is exactly what we're looking for, to see this first layer be exactly overlapping, and we'll have a flat first layer to print with. But still, I have a couple of these reinforcement pillars that aren't disappearing up into the socket. And if we look inside the socket, you'll notice that the reinforcement pillars are sticking up into the socket. And again, that's okay. We're going to end up using Vase Mode 3D printing, and you won't see any of that on the inside part of the scan. So I'm going to hit accept, but go back into transform. Sorry, not duplicate. Edit and transform. And I'm going to pull the green box upward and move the green arrow upward until we really have these reinforcement pillars disappearing all the way up into the socket. So again, depending on how narrow or wide your limb shape, this is very much going to vary how much you have to pull these up in order to get them to completely disappear. We can move them around so that they are relatively spaced out even on both sides of the receiver. And we want to look around the socket to make sure that they're all disappearing up into the socket as they are right here. Then the last thing is to make sure that the first layer is going to be completely flat. And again, the way that we determine this is that the shimmering aspect of the reinforcement pillars and the distal aspect of the receiver. So we're going to get this extremely close, but you'll notice that I can't quite see that from either point of view. So we'll get it to right there, and notice on the top left-hand part of our screen in the translate Y, we're going from 24.929 to 25.391. And 25.855. So we really want to fall in between here. So we'll try at 25.55. That goes down a little too far. So let's go up to 25.6. Not quite. 25.8. That would be too far up. 25.7. And now we're starting to see that shimmering aspect that is going to ensure that we have the reinforcement pillars and the circumference of the receiver as one solid layer. We'll hit accept. We will duplicate the reinforcement pillars, turn off the visibility of the first reinforcement pillars, hold down Control on our keyboard, click on to test socket so both of these are selected, and hit combine as well. So now all of this would be the main body of our Vase Mode test socket. We can save this, and one little trick we have to determine where should I drill out the 4 or 5 holes in the distal limb shape here, in the distal aspect of the socket. I have the 5-hole drilling guide. We're going to turn on that visibility of that particular device, and you'll notice that it is exactly overlapping the first layer of the reinforcement and the receiver. Selecting the drilling guide, going to Edit and Transform. I want to move this down exactly 1 millimeter, so -1 millimeter. And that is going to be our first layer. Now, this is going a little bit against what I was saying before. We're actually printing the first layer in non-vase mode so that we can have these holes actually showing up into the first layer of the socket. And then through some of the power of slicing magic, we print the first layer in non-vase mode and then transition up to vase mode on the second layer for the receiver and the reinforcement pillars and the rest of the socket. So we'll accept that. And now I want to be able to have the drilling guide go all the way out to the edges, the extremes of the reinforcement pillars. In order to do that, I'm going to click on to generate face groups, turn up the angle threshold to the R in threshold. We'll hit accept. Go to select. We'll turn down our brush size, and we want to zoom in on and double click, left click, just the very outer surface, outer edge of the drilling guide. We'll go to edit and extrude. And what I want to do is extrude this outward in a normal direction until it's covering the reinforcement pillars, and I'll be hardening this 100 again. So if we extrude, let's say about 10 millimeters, this might differ depending on how large of the reinforcement pillars you have. But we want to make sure that they're extended just past the reinforcement pillars all the way around the socket. It doesn't need to be extreme. Maybe we even extrude only 9 millimeters. But we want to make sure we're not falling off the edge of any of these. So at 9 millimeters, this seems appropriate. All of the reinforcement pillars are inside the edge of the drilling guide. We'll hit accept. You can clear that selection. We are going to duplicate that 5-hole drilling guide, turn off the visibility of the first one, hold down Control on your keyboard, left click on test socket, and combine one more last time. So now you have designed what is a vase mode to be 3D printed with a 2.5 millimeter nozzle for 4 millimeter wall thickness, all the way uniform shape throughout for a bulldog lock distal end. I hope this was informative. We will continue on with other designs for sockets, including suction, either vacuum, and again, you can use this design for some different materials, either polypropylene, PETG, or carbon fiber polypro. Thank you everyone for listening into this Meshmixer Master Course module, and tune in for more. Thank you, and happy printing.